Hello and welcome to the last section of web development with AngularJS 2.0 and Bootstrap. In this section, we are going to understand reactive programming, RxJS, using observables in Angular 2.0. Functional reactive programming is a software development paradigm, and it is being used everywhere whenever there is a sync stream of data coming over time. Let's start exploring. We will talk about how RxJS is helping Angular 2.0 development for async behavior of services. In this section, we will cover reactive functional programming, or FRP, asynchronous data streams, operations on stream map filter reduce, RxJS observables and promises, subscribe observables, accessing the data from observables from services. In the first video, we will understand the basics of reactive functional programming, and we'll see how observables are helping us to deal with asynchronous stream of data. Reactive programming is programming to deal with asynchronous data streams coming over a period of time. In this way, this isn't anything new. Your typical click events are really an asynchronous event stream on which you can observe and do some operations. A click event on the stream will generate X and Y coordinates, or you can talk about EX1015 generations, which also generate value over time. So it's just a stream of data on which we can run our operations. Let us unfold the mystery of reactive programming. Let's talk about what you mean by a stream. It's a flow of data over time. To get more on stream, the best place to look for these animations is the data marbles from the rxmarbles.com. Here you can see these visual layouts to make things easier to understand. Here we have different actions which we can perform onto the data streams, like filter, find, concat, and merge. A stream can be used as an input to another one. Even multiple streams can be used as inputs to another stream. We can perform all different types of operations onto the stream. You can merge two streams. You can filter a stream to get another one that has only those events you are interested in. You can map data values from one stream to another new one. A stream is a sequence of ongoing events ordered in time. It can emit three different things: a value from the stream, of some type, a completed signal. Consider that the completed takes place, for instance, when the current window or view containing that button is closed. We capture these emitted events only asynchronously by defining a function that will execute when a value is emitted, another function when an error is emitted, and another function when completed is emitted. So these are the three different events which are getting emitted from this stream. The listening to the stream is called subscribing, which follows the observer design pattern. The functions we are defining are observers. The stream is the subject, or observable, being observed. This is precisely the observer design pattern. Here we have an example of a stream where we are doing debounce operation. The notion that is missing, and which is the heart of the functional reactive programming, might very well be the stream. A stream is a sequence of values in time, as simple as that. Take, for example, the following stream of numeric values, where each value is issued every 1 second. Data here is coming over time in the form of a stream. Like here, we are getting the data like 4, 5, 6, 7, 8, 0, 1, 2, 3, 4. Another example of a stream is a sequence of mouse clicks onto the browser screen and capturing the X and Y mouse coordinates of the mouse click. Everything that happens in the browser can be seen as a stream data coming over time. The sequence of browser events that are activated when the user interacts with the single page click event and touch event on the browser screen. Let's talk about how to work with these streams of data. As they are asynchronous, we need to capture data from this asynchronous stream using observables. The observable will help us to deal with async streams. We always need to create a data stream from these different ways, like from the backend STDP calls. Browser clicks after we need to subscribe to them make them activate from the passive state and react to new values, and combine streams data together to build new ones. One important thing to keep in mind is that observables are not streams. Those are two different concepts. What we need at this point is a library that can deal with asynchronous streams of data coming over the time. And that's where RxJS comes into picture. And observables are implementations of RxJS.in.introducing RxJS. RxJS stands for Reactive Extensions for JavaScript, and it's an implementation of observables for JavaScript. To see it in action, here is the same numeric stream we mentioned above, defined using RxJS. The essentials of how RxJS work. Let's go back to the simple numeric sequence observable presented before and add a side effect to it. Here we have a simple observable example. varObs equals rx.observable.interval parentheses 500 parentheses dot take parentheses 5 parentheses dot do parentheses I equals greater than console.log parentheses I parentheses. Note that you probably want to avoid that do operator, as its only purpose is to provide side effects. If you run this program, you might be surprised by the fact that nothing gets printed to the console. This is because of one of the main properties of this type of observable. Let's run this by subscribing this observable. Observables are either active or passive. If this plain observable has no subscribers, it will not be triggered. To trigger the observables, we need to subscribe them. The observable is said to be passive because it does not generate new values if no subscriptions exist, or if there is no one to trigger it. To get the numeric values printed to the console, we need to subscribe to the observable. obs.subscribe. With this, we get the numeric values printed to the console. But what happens if we add two subscribers to this observable? So this is just an overall summary of whatever we have talked till now. In this video, we have seen the concept of functional reactive programming with Angular 2 using observables, a new asynchronous programming concept, the stream data coming over the time, a new primitive type, observables to deal with Angular 2, functional reactive programming, and RxJS. The essentials of how observables work. Commonly used operators, map, filter, reduce, scan to perform these actions and to the stream of data. In the next video, we will talk about observables with RxJS in Angular 2.0.